Noah built a floating ark for every animal. Solomon covered a sanctuary with cedar and gold. Nehemiah rebuilt a broken city wall in 52 days. Which of these is the Bible's greatest engineering feat, and how could they possibly have done it? In this video we'll examine the biblical description, test the technical details, look at what archaeology confirms or disputes, and finish with a practical verdict you can use in church or the workplace, why that question, and how we'll judge it. First, how do we decide what greatest means? We'll use for criteria: 1. Scale, sheer size or volume, tons of material, number of workers. 2. Technical complexity, joinery, metallurgy, hydraulics, logistics, or unusual solutions. 3. Logistics and resource management, procurement, transport and skilled labor, often across regions. And 4. Evidence and plausibility, archaeological remains, contemporary records, and modern engineering simulations. We'll look at 3 strong contenders: Noah's Ark Genesis 6-9, Solomon's Temple 1 Kings 5-7, 2 Chronicles, and Nehemiah's Wall Nehemiah 2-6, and test each against these criteria. Which one do you think wins? Comment Ark, Temple, or Wall. We'll pin the most popular prediction. Candidate 1, Noah's Ark, what the Bible says and the core engineering claims. Genesis 6 gives surprising technical detail, a single vessel with explicit proportions. The text Genesis 6:15 records the vessel's dimensions in cubits, length 300, breadth 50, height 30. That ratio, roughly 350-30 cubits, produces a long, boxy hull. Ancient cubit estimates vary, roughly 45 to 52 centimeters, but using a standard approximately 18-inch cubit gives an ark around 450-75-45 feet, approximately 137-23-14 meters. The text specifies 3 decks and a single door in the side. Gen 6:16. Engineering questions immediately arise. Can a wooden box of that length float stably? Can a mixed animal cargo be kept alive? How would one source and process the timber? How could a single family manage such a construction and care for such cargo? Modern engineering perspective on a wooden ship that big. Modern naval architects have run simulations and scale models. Some studies point out that the ark's rectangular proportions would be extremely stable, not a fast ship, but a stable floating box. Naval tests, including publicized work by parties in Korea and elsewhere, suggest that a blocky hull of those proportions can be seaworthy and stable in waves, particularly if subdivided and properly reinforced. However, building a wooden hull this size creates structural challenges. Wood expands, contracts, and bends. Long timbers must be joined and reinforced. And a single continuous hull of that length without modern adhesives or metal fasteners would face huge shear forces. Some engineers propose internal bracing, crossbeams, and segmental construction to address those forces. On the care side, managing animals and food for possibly months raises enormous logistical needs: feed storage, sanitation, ventilation, waste management, and disease control. Proponents argue that stall systems, separation, and ventilation shafts could work. Skeptics stress biological diversity problems and DNA, species distribution issues. Archaeology and debate, evidence, headlines, and scholarly caution. There's been intense public interest in ark remains. Turkey headlines and recent radar studies have been in the news, but mainstream archaeology remains cautious. Geological formations can appear ship-like, and the archaeological standard requires controlled excavation and peer-reviewed material evidence to claim a human vessel. News reports and some private research teams have found intriguing shapes and geophysical anomalies near Ararat, but these findings are not accepted as conclusive by the wider scientific community. So, Noah's Ark as a text describes a plausible, if extraordinary, wooden floating structure. Engineering models suggest such a hull could float and be stable if designed for buoyancy and bracing, but the biological and logistical demands are huge. Archaeology currently provides tantalizing but disputed claims. There is no consensus proof of a found ark. Candidate 2, Solomon's Temple, the biblical build and what the text records. Solomon's Temple, a candidate that combines architectural finesse, metallurgy, long-distance resource procurement, and elite craft. The biblical narrative 1 Kings 5-7. 2 Chronicles gives detailed dimensions, materials, and the logistics. Cedar and cypress from Lebanon, skilled Phoenician craftsmen under King Hiram of Tyre, and elaborate bronze work including the enormous molten sea to monumental pillars Jachin and Boaz. The inner house is described as 60 cubits long, 20 wide, and 30 high 1 King 6-2. The Holy of Holies is a 20 cubit cube. The engineering pieces to notice: a massive materials, extensive cedar beams Lebanon, gold and bronze overlay, carved stone and worked wood. B. Metallurgy scale: bronze casting of large basins and the molten sea described as hundreds to thousands of baths in volume, requiring major foundry capacity. C. Skilled labor and technical know-how: Phoenician artisans were world-class shipbuilders and metal workers. Their involvement is historically plausible. And D. Logistics: timber had to be felled, floated as rafts to the nearest port and overland to Jerusalem, a long supply chain. Engineering plausibility: metallurgy, cedar shipping, and Phoenician skill. Archaeologists and historians point to a plausible engine behind the biblical account. The Phoenicians were masters of long-distance timber and ship logistics. They operated large sawmills and crafts. The biblical record of Hiram's assistance aligns with known Phoenician capability. Bronze casting on the scale described is technically feasible in the Iron Age. Archaeologists find large smithing complexes and hoards of metals across the region. Where scholarship is cautious is in direct archaeological evidence for Solomon's temple itself. The Temple Mount has been a politically sensitive place and extensive archaeological excavation on the mount is limited, making direct material proof scarce. Still, archaeological parallels, large Iron Age temples and grand palaces across the Levant, show the technical repertoire existed. If your measure is technical complexity plus logistics plus elite craftsmanship, Solomon's temple is a very strong contender. Large-scale metallurgy, architectural design, and international supply chains all appear in the text and are consistent with known regional capabilities. Candidate 3, Nehemiah's Wall, 52 days, rapid build, and project management brilliance. Finally, Nehemiah, not necessarily a dazzling monument of metal and gold, but an astonishing feat of project management, logistics, and security under pressure. The biblical account says Nehemiah inspected the ruins and then organized Jerusalem's inhabitants into section teams. Gates and the wall were repaired and completed in 52 days, Nehemiah 6:15. That speed is the claim that turns this into an engineering puzzle. What makes Nehemiah's project technically significant? 1. Mass mobilization. Families and guilds assigned to sections. Nehemiah 3 created parallel work streams, increasing throughput. 2. On-site risk management. The builders worked with weapons and shields when threatened. Therefore, dual-role workers. 3. Local materials and repair focus. Much of the job was repair and reuse of stones and walls rather than cutting new megaliths. 4. Leadership and morale. Nehemiah's rotating guard strategy, on-site presence, and local ownership generated unusually high labor intensity. From an engineering standpoint, this is less about technological innovation and more about organization, continuous quality control, and security integration during construction. Archaeology and feasibility. What we can and can't prove. Archaeology interacts differently with each feat. For the temple, direct excavation on the Temple Mount is extremely limited for political and religious reasons, so direct proof is scant and debated, though regional parallels and some inscriptions may hint an Iron Age temple tradition. For Nehemiah's Wall, archaeological surveys around the city and finds in the Iron and Persian period layers give context for city walls and fortifications, while precise matching to Nehemiah's 52-day narrative is interpretive. The reconstruction shows a plausible program of repair. For the archaeological case remains contested with no consensus-confirmed site. In short, Temple and Nehemiah projects have strong textual and contextual archaeological plausibility. Our claims remain more in the realm of debated historicity and engineering models. For balance, archaeology rarely produces one-to-one confirmations of narrative accounts. Instead, it offers plausibility through material culture and parallels comparative analysis, scale, complexity, evidence, plausibility. Let's apply the 4 criteria we set earlier: scale, arc, enormous hull. Potentially the largest wooden structure described in ancient texts. B. Temple, massive materials across many categories: timber, stone, gold, and huge bronze work. C. Wall, large linear extent around the city, not one superstructure but a network of fortifications. Technical complexity, 1. Arc, heavy structural engineering questions, animal care logistics. 2. Temple, advanced metallurgy, decorative work and joinery, high technical craft. 3. Wall, intensive stonework and logistics, but technically simpler stones than precision metal casting. Logistics and resource management. 1. Arc, single site mass resource use timber, food, enormous provisioning. 2. Temple, multi-region procurement Lebanon timber, tire artisans, shipping and sustained supply chains. 3. Wall, local labor mobilization and reuse, high human logistics but shorter supply chains, evidence and plausibility. 1. Arc, textually detailed. Modern engineering suggests possible floating platform but archaeological proof is lacking and contested. 2. Temple, rich textual detail, Phoenician parallels and known metallurgy make it plausible. Archaeological access limits direct proof but regional parallels exist. 3. Nehemiah's wall, strong textual narrative and local archaeological context for walls and fortifications. Project management aspects are historically plausible. If your metric is sheer structural novelty, the arc looms large. If you focus on technical craftsmanship plus international logistics, the temple stands out. If you prize operational speed under threat and social engineering, Nehemiah's wall is a masterpiece. Each is great in different dimensions. My verdict, a balanced, evidence-aware winner. I'll give you a clear, defensible verdict based on the combined criteria. Solomon's Temple is the most convincing candidate for Bible's greatest engineering feat when we account for technical complexity, multi-regional logistics, and specialized craftsmanship described in the text and matched by what we know of Phoenician capability and regional Iron Age craft traditions. The casting of enormous bronze objects, the use of imported cedar and cypress, the scale of gold overlay, that combination points to a complex, multidisciplinary engineering and supply project unlike the others. But a crucial qualification, direct archaeological proof on the Temple Mount is limited by political and religious restrictions. So the argument is based on a robust congruence of textual detail and regional technical capability rather than a single excavation find. Nehemiah's Rebuild is a close runner-up for project management genius. Noah's Ark remains in a distinct category, an extraordinary engineering narrative that is technically arguable but archaeologically unresolved. Do you agree? Comment Temple, Wall, or Ark and tell us why. What engineers and leaders can learn, practical applications. The Bible's engineering stories also teach leadership and practical lessons you can use today. 1. Design meets culture. Solomon hired Phoenician experts, recognize when you need external skills. Outsource the right expertise. To parallelism and ownership, Nehemiah assigned families to sections, divide large projects into owned work streams to multiply throughput. 3. Plan for provision and maintenance. The temple required ongoing resources, tithes, upkeep, plan not only to build, but to sustain. For engineering humility, Arc logistics remind us to model for complexity, plan for the hidden needs waste, ventilation, animal health. 5. Security plus production. Nehemiah shows you can build under threat by integrating security into operations rotations, watch teams. Whether you're leading a charity kitchen, a startup build, or a city infrastructure project, these ancient narratives show practical patterns that still work. Summary. Arc, giant floating platform with debated archaeology but plausible engineering features. Temple, the strongest candidate for greatest feat because of combined technical complexity and supply chain scale. Nehemiah's Wall, an organizational engineering marvel. We've dropped the primary sources and a reading pack in the description, Genesis 6. 1 Kings 5-7, Nehemiah 2-6, plus modern resources that inform this video. Like, subscribe, and tell us which ancient feat you want us to model next. Build well.